Hey guys, hope you're having a good day. I'm having a great day. Today I want to talk about performance in queue tables within your database as well as audit log tables, since they both kind of follow the same process in inserts. Now, queue tables in recent years have been moved out of the database into dedicated queue services like SQS and Amazon, as well as RabbitMQ and some other queuing services. But there is still some use for queues in a database, particularly if all your data resides within that single database. That way you make it one trip. I don't want to get into the benefits and the negatives of having a queue in your database outside of using external service. But I will say, for the most part, if you can get away with an external service these days because of the cheap hardware, it might be better to use that. With that said, queues are still a thing in databases, so let's talk about them. Often, where you have problems with queues as far as performance goes is when you have a high volume of inserts going in. Queues will normally have an identity column. So the first record inserted will be 1, and then your identity will be 2, 3, 4, 5, and just sequentially increase down the road. The reason what makes this efficient is for two reasons. First is you're not having to place the data all over the queue table. It's always going to the far right-hand side of your queue table. The second thing is when you go in to retrieve from the queue table, you have your high watermark that the application is maintaining, and it's going to grab a range from there. Maybe it's the top 1,000, top 5,000, or give me everything, that's greater than this. And that will, that's efficient in a database on a B tree because it's going to do a range scan at the very root level of your data. Sorry, be the leaf level of your data. I always get those two words confused. But in creating this performance increase, you also do get a problem there. When you have a high volume of data coming in, everything is getting inserted into your B tree on the far right-hand side of your B tree, if you're looking at the B tree. Of course, that's hypothetical. But everything is getting inserted, and there are locks on those data pages. So, for example, when you insert number 7 has to take a lock, it does the insert, and then it releases a lock. Meanwhile, record ID 8, record ID 9, record ID 10 have all started coming in, and they are waiting for 7 to complete. And then when 7 is completed, 8 comes in, and then it could start to back up in a high volume system. If you're getting 10, 30, 20,000 per second inserts, it can start to cause problems. One way to get around this is through partitioning. And you'll see, is to stop this locking, is because when you create partitioning, you're essentially creating, let's say you have 5 partitions, you're creating 5 different B trees. And therefore you'll be you're distributing your partitioning, or you're distributing your inserts over 5 different B trees, and you're not going to have as much contention, 5 times less contention there. The problem that occurs with this situation is in a data retrieval. SQL Server does a great job of doing range scans, but when it's doing a partition, when it has to deal with partitions, it doesn't do a range scan. If you say, give me everything greater than 100 on a single partition or a single B tree for the table, it's going to say, give me everything from 100, it's going to start sliding right across, running across and get all your data. But when you're talking about a partition table, and you have 5 different ones, SQL Server isn't smart enough to do a range scan on each one of those partitions. It'll actually do a full scan, and this can be detrimental to your applications. So you have to do a little trickery with some hints. So essentially the way you would do this is you would hint and say, give me everything greater than 100 where partition equals 1. Give me everything greater than 100 where partition equals 2, and so forth and so on. Put that into a temp table and then say select all from this temp table. It's a little less efficient on the retrieval of your data by partitioning than it is to do, but you get your performance on the inserts. And because retrieval is usually happening on the background, it's probably more efficient to do this than holding transactions open while you're doing the inserts. Read transactions are a lot easier than write transactions, and if you're doing a dirty read, then it's even better. Same thing is true with an audit table, except an audit table is a lot more easier because, again, it's usually inserted into an identity column, and you don't have to retrieve it. Usually you don't have to retrieve it, and therefore it's even better to partition on that. So this is a little hint to avoid blocking on your queues and on your audit tables. I hope you found this interesting. You guys have a good day. Bye.